Okay, today I'm going to show you some tools that you can use to manage the import structure of a large Lean project, in particular Mathlib. The place we're going to start is with a tool called Pole, which tries to compute the longest pole while compiling Mathlib. That is, the sequence of files required to get all the way through compiling Mathlib that takes longest. If we've got multiple CPUs, of course, other files will be compiling alongside, but the longest pole is the part that determines the compile time. I'm going to run lakexe pole with the flag --loc, which will just make things a little bit simpler and faster here. This doesn't actually look at the real instruction counts for compiling files, it just uses the number of lines in each file as a proxy for the duration of each file. Let's pipe the output to a file pole.md. Once we've got that, we can open that up in Visual Studio. And you can see it's a markdown table. All of these tools are, of course, written in Lean itself. And maybe we can switch that to the preview mode. So what do we see here? Well, it's a whole list of files. At the top is Mathlib, and below that is the longest pole. So you can see here that the very last file to compile in Mathlib is going to be mathlib.numbertheory.fermat's-last-theorem.3. It depends on numbertheory.cyclotomic.3, and so on down. You can see it goes down through some number theory, some measure theory, some analysis, more measure theory, onwards and onwards into some topology, some order theory, some theory of finite sets and multisets, down into lists and sets, ordered structures, into some metacode, and all the way down on into batteries and Lean itself. Okay. For each file here, it's showing, well, the number of lines of code in that file. If we'd run that without the -loc, it would tell us the instruction count for compiling that file, and it gives us some other information about where we're up to in the longest pole. Okay, that's all very interesting, but what we'd like to think about is maybe how we can reduce this, how we can improve the import structure in Mathlib. There are a bunch of ways to do this, but what I want to show you today is a new tool that analyzes this automatically and gives us a bunch of useful information. So let's run that as scripts / unused in pole.sh. We can either run this as is, or we can specify some particular target. We could work out the longest pole in all of Mathlib, or we could pick some particular file that we're interested in and do the analysis there. Let's run that. Great, okay, that's finished, and it's written some output here. It's told us that it's written a table to unused.md, and it's also given us a bunch of command lines that we can run that will give us some further information. We'll discuss those later, but let's first of all look at unused.md. This is a markdown table, so let's switch to preview mode so we can actually see what's going on. Okay, so again, it's showing us the files in the longest pole on the way to compiling all of Mathlib. But now, as well as all of these numbered rows, we have columns using the same numbering scheme. And then we've got a big table, and entries in this table are filled in with an X, tells you that this file here, numbertheory.cyclotomic.discriminant, which is file number 4, imports file number 19, so that's down here, mathlib.measuretheory.integral.setIntegral, but it doesn't actually make use of any of the imports, of any of the declarations, rather, from that file. So all of these X's are telling us about a transitive import that isn't actually used. So you can see here that this table is pretty interesting. What it's doing is telling you, well, at least when you see a large rectangle worth of X's in here, so we see a big rectangle here, or we can go out into other places and see giant big rectangles of X's down here. That tells us that there's some big chunk of files corresponding to the rows of the rectangle, which transitively import some big chunk of files corresponding to the columns now of that rectangle, but don't actually use any of the declarations from those imported files. So anytime we see a big rectangle in this table, that's a great sign that we might have some import reduction we can do. Now, these commands that are being printed out for us here are exactly obtained by looking for the largest rectangles in this table and identifying where they sit in Mathlib. So these are all commands here which will generate a graph using LakeXEgraph, which is our tool for visualizing parts of the import graph. Let's actually just run all of these commands and see what we get. We can open them. Wow, okay. So we have lots of things here. So these are all showing us little snapshots of the whole import structure of Mathlib. There's some file down at the bottom here, mathlib.order.filter.basic, and then a bunch of files that it imports, all the way up to some other specified file, mathlib.data.finset.basic. Now the special thing about these graphs is that the tool shades in grey any file which is transitively imported by the bottom file, but none of whose declarations are actually used. And so this can give us good clues about places that we might do some splits. For example, here we might try and work out how to split mathlib.data.finset.image into two parts. One which uses mathlib.data.finset.union, and another part which doesn't use mathlib.data.finset.union, but provides everything that is needed for mathlib.order.filter.basic. And if we could do that, then we would break this transitive dependency and be able to remove well, half of this node from the import requirements of the final file. This one is maybe actually not the most practical example to look at. Let's have a look at some of the other ones that come up. Here, for example, you can see something maybe a bit more interesting, that there's a big chunk of files here that are all grey, and that maybe suggests that we might actually be able to remove all of those from the import requirements of topology.algebra.infinitesum.group, probably by modifying this file and breaking that into two components. I'll just quickly go through the others here. There's a giant one here. There's another one here with lots and lots of grey nodes, perhaps data.list.perm, the parts of that are needed for multiset.range. Might not actually need all of these imports. So on. This is another massive one. This one actually is an interesting one, and I think it's actually the rectangle we looked at first. These files, mathlib.numbertheory.cyclotomic.discriminant needs mathlib.numbertheory.numberfield.discriminant, and that then imports basically all of analysis and measure theory, but all of that analysis and measure theory, while some of it is used in this file, is not actually used in this file. And that strongly suggests to us that this file perhaps is something that we might want to look at splitting. Okay, let's go ahead and do that split. We'll move over to a new branch of Mathlib. Okay, so the first step, well, I guess is opening up the file. Which you can see imports these substantial pieces, these files which in turn imported lots of analysis. So our first step when splitting a file, this is just numberfield/discriminant. I would suggest we create a new directory called discriminant. We move that file into it and rename it to basic. And then have a quick look around Mathlib to see who imports it. There aren't many imports, so we can just change these manually to import the new renamed file. So at the moment we've just moved a file. And if we save all of those, we should be able to check that Mathlib still builds. Of course, here we're touching a file which is very late in Mathlib, so after we make a change, it's quite fast to run Lake build. If we were working lower down in Mathlib, you might just have to leave this running while you proceed. Now, the basic tool we're going to use to to work out how to split this file is this great linter called min imports. What this does is processes the file, and every time we do something that requires more imports, it prints a little warning message. So you can see here that as soon as we open the namespace number field, it tells us that we would have needed to import this file, mathlib.numberfield.basic. Oh, sorry, I'm in completely the wrong file. I'm not meant to be modifying class number. Let's remove that and go back. Where were we? We were meant to be doing discriminant.basic. Yes, the file we renamed. Okay, so let's just put set option linter.minimports true there. And we can see that we get to this definition of the absolute discriminant of a number field. And at this point, we need a few more imports, but it still looks all pretty simple. It's just number theory stuff and some very basic files. We prove a few theorems. And then when we get up to this line, suddenly we're requiring this file that we saw before in our graph, which was the one that then imported all of analysis. So perhaps it's at this step that we want to split things. So the suggestion I'd make is that we just go and make a copy of this file. We'll call it defs. And in the defs file, what we're going to do is just reduce the imports to only what was needed to get up to this initial segment of the file. So we'll take these, we'll delete all the current imports, clean these up. Okay, let's see what happens. Oops, I must have mistyped something there. Great, okay, so the first part of the file still compiles, but as soon as we get to this part of the file, which required more imports, of course things go wrong. And all we're going to do is just start deleting everything that goes wrong. Because of course these things we delete are still over in the basic file, which we haven't touched. We're just making a much smaller file now, which has the parts that do work with the more limited imports. So this looks like it works, so let's leave that for now. But this doesn't. Nor does this or this. But then it looks like the tail end of the file does work with these more limited imports. Okay, just going back up here, we've got this section namespace Hermite theorem, and I think the things inside there were just some preparatory facts for the things we deleted. So I'm just going to go ahead and delete this as well now, on the basis that it probably belongs in that later file, and that comment should probably go as well, since that'll be in the later file. We can do a little bit more cleaning up here. We've got a section being closed, so we can delete some variables and open statements that come towards the end of that. We can remove this helpful min imports linter now that it's done its job. And we probably should update the module doc here and remove that main results section, because those are things that we deleted. Great, okay, that file compiles. Let's now jump back over to number field discriminant basic, and what we're going to do is add the import for the file that we just created. This time I guess we can clean up the other part of the module doc. And now, of course, there are errors in this file, just telling us that some of these things have already been declared. And so we delete those things. Now that we're at the end of the file, we have some more things that were in the previous file, an empty namespace there, and some variables we can clean up. So far, that looks like it's gone great. This file is compiling. Notice at this point we haven't actually done anything about cleaning up imports outside of here, but that's fine because we actually have automatic tools that will do that for us. Let's just quickly rebuild Mathlib. And then we'll use lakexe shake. This should automatically clean up imports for us. And indeed, you can see it makes exactly the change we were hoping for. In number theory cyclotomic discriminant, it tells us we no longer need to import discriminant.basic. We can get away with just importing discriminant.defs. It also makes a few other suggestions in discriminant/defs. It says that we can actually get away with less than what we initially thought. Okay, let's run lakexe shake again, this time with ---- fix to actually edit the files. We can do a final lake build to check things look okay. Things don't look okay, so I guess we've got something to fix there. Let's open up that file with the problem. Okay, so it's actually just in an open statement. Possibly something I guess we missed when we were doing before is we should have tried to clean up these open statements, just deleting things and seeing if they're actually needed. And it does appear that they're not. So a quick look through the rest of the file. Great, no more stray open statements, and so let's try that let build again. All looks good. At that point, we can just run git status, have a look at things. Oops, we've of course created some new files, so we better git add those. And since we've created new files, we should run lakexe make all to rebuild mathlib.lane. After we've done those things, though, we can make a commit. It probably counts as a chore. Split number theory / number field / discriminant, and send that off as a PR. Let's add a little bit of a comment. Splits into defs and basic. Defs suffices for cyclotomic / discriminant and doesn't require much analysis. Basic contains Hermite's theorem. Great. Okay, let's send that off, see what people think of it. And now we're almost done. What I would like to do now is jump back here into Mathlib and look at the longest pole again. Oops. Okay, let's take a look at that. And in fact, we have completely changed what the longest pole is here. Let's just drag this over so we can compare them. Previously, it was this Fermat's last theorem.3 file after some cyclotomic stuff. Now we still end in number theory, but now with a file under Dirichlet continuation. You can also see that the length of the longest pole, at least measured in lines of code, did drop a bit. It went from 108,000 to 107,000. It's a small improvement, and in fact it's a different path. So we could probably profitably rerun that whole tool to analyze the unused imports in the longest pole and find other interesting things to do. But for now, I'm going to leave that there. Oh, maybe it's actually worth saying back over on this PR we made, this bot has automatically posted. Um, and one thing that it's told us is that no declarations were harmed in the making of this PR. So that's telling us that we did successfully split those files without accidentally dropping anything. And it's also given us a little report about how we've changed dependencies. In particular, what we've managed to do here is reduce the number of imports for number theory.cyclotomic.discriminant by about 366. Somehow we've increased the imports to number field.class number. I'm a little bit confused by that, but anyway. And actually, there are some other files here which we've also managed to reduce the number of imports for.